So let's define a function. Okay, so go and write the word function. Let's underline this puppy. Thought I could underline it. Here it is, a relationship in the form of an equation between input values x and output values f of x. A relationship in the form of an equation between input values x and output values f of x. Now the way to read this right here, f parentheses x, the way to read it, put in quotations, write f of x. That's the way to say that. Rojas has me for math 3, so he's kind of used to this. This is a little higher level math now. Instead of x and y, we're now going to replace y now with f of x, because y is a function of x. Just write this down for now. It's going to come more clear right now. That's right, it always happens. So, underneath that function definition, go ahead and write y equals x squared. So go and write the equation y equals x squared. Right, this is f of x. This means f of x. So this little quotation here, f of x, this is how we say f parentheses x. So when we write f of x, or the f parentheses x, the way we say it is f of x. And let me explain what that means. So when you write the equation y equals x squared, go ahead and put an arrow on x and put input. And whatever y is, put outputs. So put an arrow on x and put input, and an arrow on y and put output. Stay with me. Very short note session today, very easy. Watch this. If I were to make a table of values, do this on the side now, do it with me. Remember a while back I asked you to graph. We can choose any values for what, x or y? If I ask you to choose some values, you put them for the x or you put them for the y? X. Yeah. Right, so if I ask you to choose some values to graph this, you always choose values for x. Because that's the input. It's like a machine. Look at it's just called like a function machine. You put things into a machine and the machine spits stuff out. Input, the machine does something with it and it spits some out. We call it the output. So see a function, an equation like a machine. You input values of x and it outputs values of y. So watch this. What's your favorite number, Moreno? What will be the output? So look at what I'm doing. I'm putting in a 5. What's the machine going to spit out? Close. 25. Because, right, 5 to the second power is 25. So do this with me. Sevilla, what's your favorite number? So look at what I'm doing in the machine now. I'm inside the machine. I'm putting inside a 10 in the machine. The machine does something with it. What does the machine spit out for the output? 100, huh? Okay, we're starting to see it now. Now, whatever y was, whatever y became, thank you, gentlemen, talking. Whatever y became depended on what x was. Let me say that again. Follow me, track me. Whatever y was, like 25, 100, and we can keep doing this forever until the cows come home. Y depends on what x is. So because y depends on what x is, we say in English, y is a function of x. So the word function of is the same way as depends upon. For instance, you passing my class depends on you being here and getting your stamps. Notice I use the word depends. You passing Mungia's class depends on you showing up and getting your stamps. Now let me re-say that sentence with the word function. You passing my class is a function of you showing up and getting your stamps. So in the English language, when we say something depends on something, we can say that something is a function of something. So since y depends on what x is, look what I'm going to do now. Stay with me. I'm going to write f of x. Y is a function. Look at y is a function of x. I'm going to rewrite the equation like this now. This means this. It's just a little higher level of writing equations now. We're going higher level. So underneath y equals x squared, we're going to write f of x equals x squared, and going to write same thing. Same thing. F of x equals x squared really means y equals x squared. Why does it mean the same thing? Because y depends on x. I just gave, look at, we had Moreno's favorite number. That was x, and what did y become? Y depended on Moreno's favorite number. This value of y depended on Sevilla's favorite number. It depends on x, therefore it's a function of x. So we can rewrite y as f of x. F of x now, from henceforth in this class, f of x means y. I want you to make that small slight shift in your head, that f of x means y. Now watch this. We're pretty much done with our notes for today. I told you it's going to be easy. Watch this. Here's another function machine. Look at my function machine. Look at this function machine. You can drop your pens now. Watch my function machine work. Here's your inputs. Just pay attention. And then your outputs. It spits out something. The insides of the machine can do different things. Right now, the inside of the machine is going to put, it's going to favorite, here's what the machine does. Favorite football team. The machine does that. If you put something in it, it spits out the favorite football team of that thing. Watch this. First input, Mungia. Look at the output. I'm going to the office. Hold on. Murillo. So he's the input. What is it going to spit out? Anybody? What is it? The whiners? The whiners. The San Francisco 40 whiners. If I put in Magana, the what? You guys with me? We'll give me. What should I put for the Steelers? All right, here we go. Williams. So look at, we have the same output now. Steelers. So two different inputs but the same output. And that's okay to have for a function to be that way. Two different outputs for the very same input. Now, Okay, that's favorite football team. Watch this. Watch this. No, no. This is number of siblings. Look at input, Williams. Hit it. My mom. Oh, 13. Okay, so my mom she had 13. She had a lot of siblings too. All right. Here we go. Hernandez. Hernandez is an input now. Hit it, Hernandez. Castillo. 8. Relax the language. Okay, so you guys are getting it. There's input, spits out outputs. Now, for 35 tickets. For 35 tickets, count them.